Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. So today I am going to discuss about the magnetism and a matter. This is the topic where we will discuss each and everything. But this is the part one video. So let us understand what is magnet. So naturally, what happened in the place of magnesia, we have got the magnet. How just by suddenly we have seen that, or some people have seen that the iron material has is with this material. So they have considered it as a magnet. So magnets are naturally found in the nature. So some of the magnets can be artificially drawn, but basically natural. Initially, the magnet has been found in nature. So chemical formula for the natural magnet is Fe3O4. And basically, what if there is a magnet like this, and if you want to find the what type of poles it is. So magnet has a two pole, that is your north pole and south pole. So how to find out then which is north pole and which is south pole? So if we keep the magnet with the string, so what will happen? Magnet will align itself with the natural geographical north side, and the magnet part of the magnet will also align itself to the geographical south. So the part of the magnet which align itself toward the geographical north, if this is your earth and this is north pole and this is south pole, and if magnet align in this direction, so this part will be considered as a north pole and this part will be considered as a south pole. The natural magnet have often irregular shape. Okay, it is not like that it will form in a bar magnet. So basically they are irregular shape and they are weak at least. Okay, they don't have a possess any strong attractive ability. Okay, so artificial magnet. So magnet which is made artificially, it is found that the piece of iron. It is found that the piece of iron and steel can acquire a magnetic properties on the rubbing with the magnet. So let us suppose that there is a piece of iron and cobalt, iron or steel, and if we rub with the magnet, natural magnet, so what will happen? It will possess a strong magnetic property, right? So what happens? Such a magnets made out of the iron and steel and are called artificial magnet. So it has some shape. So some magnet having a bar magnet like this. So this will look like a bar like this. Some magnet will have a horseshoe shape. So this is the horseshoe shape type of magnet. It is your north and it is a south pole. Some magnets are like a magnetic needle and it will be used in a magnetic compass. So to detect the direction. So let us suppose this is a magnetic compass. So this will detect the direction. Okay, so this is a magnetic compass. I hope you have understood this. Now let us go for next. So the bar magnet. Let us discuss about the bar magnet. It is the most commonly used form of an artificial magnet which have a north pole and a south pole of the same strength at a same distance. So let us consider if this is a bar magnet and this is a bar magnet, and if you divide it into 50%, so 50% will possess a north pole and 50% will possess a south pole, and they have a same type of strength but in opposite in a direction. One more thing is that the strength of the magnet will be nearby. So if you see in the figure nearby, the magnet has attracted a lots of material. So it means that nearby this outermost edge, the strength of the magnet is strongest near the outer edge. So we will discuss about the basic properties of the bar magnet. So basic properties of the bar magnet. Every magnet attracts small piece of a magnetic substance like iron and cobalt, nickel and steel toward it. So any magnetic substance like iron, cobalt, nickel and steel will be attracted toward the magnet. So the attraction is maximum at the two ends of the magnet and these ends are called. So basically you have seen that maximum attraction will be at the end, and this is known as pole. So pole side or the end side will have the strongest strength of the magnet, right? When a magnet is suspended freely with the help of a thread, then it comes to the rest along the north and south direction. So what will happen? some parts will be aligned with in the geographical south and some parts will be aligned with the geographical north. So the part which is aligned toward the geographical north will be considered as a north pole, and the part which is aligned with the south pole, geographical south, that is geographical south means earth south. So this is your earth's north pole and this is a south pole. So due to the alignment only we can detect that which part can be considered as a north pole and which part can be considered as a south pole. So I hope you have understood these two property. Now let us go for third property. So in a magnet you will find the two axes. So if this is a axis and this is a axis, and this perpendicular line which divides it into two parts is known as equatorial line and axial line. This is the axial line. So this is the third property. Now fourth one is the like poles. So like pole will repel. Neither north pole, this is a north pole, so what will happen? Repulsion will happen. And unlike pole attract each other. See here, like pole, south pole, repulsion happens. North pole and south pole, if this is your unlike pole, unlike unlike pole, so what will happen? Attraction will happen. Attraction will happen. Okay. So I hope you have understood this. So this is the fourth property of the magnet. Now fifth one, inductive property. Let us discuss about the inductive property. When a piece of a magnetic material like soft iron, cobalt, nickel, etc. is placed near a bar magnet, it is acquired some magnetism. The magnetism so acquired is called induced magnetism, and this property of a magnetism is called the inductive property. See, let us consider we have kept a magnet like this. This is a magnet. So this is your magnet, permanent artificial magnet, and you keep a here a cobalt. So when you keep a cobalt, so what will happen? It will also acquire a magnetic property without touching. So when any magnetic material without touching will acquire a magnetic property with the nearby magnet, so the property of inducing the magnetism is known as inductive property. So I hope you have understood this before. Now let us go for a sixth one. Sixth one, the magnetic poles always exist in a pairs. The magnet poles of the magnetic can never be separated. So no matter how many break you will break down it. So let us suppose again you have break down into small, very small pieces. So even smaller pieces also contain north as well as south pole. So everywhere you will find that north as well as south pole will always exhibit together. If there is a north pole, it means there is a definitely a south pole. It is not like that if you break down, so you will get a north pole separately and south pole separately. It is not possible. Okay, so you cannot divide the north and the south pole by just breaking it. So it will remain everywhere in a even a smallest particle. So monopole, it means that magnetic monopole do not exist. Never you will see that this is the magnet and it is your north part. If there is a north part, so definitely there is south part. Even in the smallest part, if there is a north pole, so there will be a south pole. So this is known as monopole. So monopole does not exist in the magnets. So I hope you have understood this. Now let us go for next. Magnetic field. What is now magnetic field? This property is magnetic field. It is the space around the magnet or a current carrying conductor in which its magnet effect can be felt. Let us suppose this is the magnet. This is a magnet, okay? And there is a north pole, south pole. We don't know. If we keep any object and it will be repelled or attract or repulsion will happen. It means that in this area magnetic property has been filled. So this area is known as magnetic field. So the area around which magnetic repulsion or attraction can be filled is known as magnetic field. Now suppose there is a current carrying conductor. So we know that the current carrying conductor will also create a magnetic field. So this area is known as magnetic field. Okay. So these are the area where magnetic property can be felt is known as magnetic field. So I hope you have understood this. Now let us discuss about the magnetic field properties. It is the space around the magnet or a current carrying conductor in which its magnetic effect can be felt. In order to visualize the magnetic field graphically, Faraday introduced the concept of the magnetic field lines. So see here, let us suppose that we know that the magnetic field in this area is filled. But now to represent in the book or a paper, we cannot keep it in a blank. So Faraday has introduced the concept of the magnetic field lines. So basically, if you want to represent the magnetic field lines, we need to know the properties, that how it has been can be felt, or how it can be represented. So magnetic field lines, let us see. It is an imaginary curve, the tangent to which at any point gives the direction of magnetic. So let us suppose this is a magnetic field. So I want the direction of magnetic field. So tangent at this point will give you the direction of magnetic field. Okay, at any curve. There are basically two types of magnetic field. One is uniform magnetic field and another is non-uniform. So in uniform magnetic field, so the lines are like parallel. Either it is going inside the paper, or it is like this, or it is coming outside. So all are parallel to each other and all are equally spaced. So this is known as uniform magnetic field. Now the magnetic field which is not equally placed, see here, the distance between two magnetic field is larger, but at this point distance is smaller. So these are in the form of curves. So what will happen? So this is not a non-uniform magnetic field. Non-uniform magnetic field. Okay, magnetic field. Now one more thing is very important, that if the gap between the line is more, if the gap is more, magnetic field is weak. But if the gap is less, so the field is strong. So this is very important. So we can easily say that which area the magnetic field is strong and which area magnetic field is weak. Now properties of the magnetic field. So first property is that the magnetic field lines of the magnet or a solenoid forms a closed continuous loop. The magnetic field lines extending through the body of the magnet solenoid forms a south pole to the north pole. So let us consider this is a bar magnet having a north pole and a south pole. Now what happens? The magnetic field will originate from north pole. It will originate from north pole and it will go to the south pole. And from inside it will go from south pole to north pole. So it means it will form a closed loop. Closed loop. But you have studied in electric field, you will not find such as anything. In electric field you will find that inside the conductor there is a no field lines, but outside there is a field lines. But in this, what happens in magnetic field, what happens in this case, it forms always a closed loop. Magnetic field always complete their loop. So this is very important. It will never be half like this. So definitely it will be a part of the curve. So it will form always a closed loop. Outside the body of the magnet, the direction of the magnetic field lines is from north to south pole. See here in outside it is from north to south. See here, north, it will start from north and it will enter in the south. But inside it will from south to north pole. See, outside there is a magnetic field line is from north to south, and inside the magnet it will come from south to north pole. The magnitude of the magnetic field at any point is represented by the number of magnetic field lines passing through it. Let us suppose this is the area, and in this area there are how many numbers of field lines are there? Only 3. But if you talk about this, the same area, the number of field lines passing is 4. So that means that it is the strong magnetic field. While this will be the weak magnetic field, because number of field lines passing through this will be less. Now let us suppose the same area if we are taking, and number of field lines are 1, 2, 3, 4, 5, 6, 7, 8. So this is the strongest one. Understood? So the number of field lines is more, so it will create a strongest field. The number of field lines per unit area will be less, so it means that it will create a weak field, magnetic field lines. Got it? So I hope you have understood this. Now two magnetic field lines cannot intersect each other, because at the point of intersection we get two direction of the magnetic field, which is not possible. Let us suppose this is they are crossing. Now, as per you, tell me the direction of magnetic field. So, if this is like this is like this. Now, if I will tell you that at this point, which is the direction of magnetic field. So, as per the rules, so magnetic field has the magnet direction of magnetic field is at the tangent. So, this is also the tangent, and this is also the tangent. So, it means that magnetic field is in two direction. Is it never possible that at a for a same point, field lines will never give you a two direction? So that's why they will never cross each other. Okay, so I hope you have understood this. Now fifth one is fifth one is magnetic field lines exist inside every magnetized material, so it will always form inside. So inside the magnetized material you will find a magnetic field lines. It is not like that only you will fall outside. But what you have seen in electric field lines, continuous curves which are not closed loop, whereas in magnetic field lines, closed continuous loops are there. Let us consider this is a circle, okay, and there is a charge. So definitely we know that magnetic field lines are magnetic field lines will be magnetic field lines will be coming outside this. But if you talk about inside, so inside there is no magnetic field, zero. Sorry, it is no electric field. So this is the electric field coming out, but inside there you won't find any type of electric field. So it means it is not a closed loop. Also inside it will not be found. But what about the magnetic field lines? Unlike the electric field lines, magnetic field lines is found inside the magnet as well. See, if it is found outside, so definitely it will also found inside the magnet inside. So I hope you have understood this. So this is closed and continuous curves. Okay, magnetic field lines are closed and continuous curve. But in electric field lines, continuous curves are not closed. Okay. So I hope you have understood this.